In the last unit, we talked about special right triangles and how to use some properties to find missing side lengths. In this section, what we're going to do is use what's called trigonometry, or we shorten it to trig, and that would be our information of sine, cosine, and tangent. So we're going to use it to find missing side lengths in right triangles. Then we're going to use the inverses to find missing angle measurements in right triangles. So let's just jump right into it. So we have sine ratio. What that is this angle A right here. It's taking the side that is opposite angle angle A, and I should include it's the side opposite angle A, and putting that measurement over the hypotenuse. So for this figure here, the side opposite is BC, and the hypotenuse is AB. Okay, and so sine, I sometimes will write it as like this, so, S-O-H. And this is where your, oops, I don't have a picture of it, but it's where your SOHCAHTOA thing on the very front of your foldable, where that comes from. So some examples of this using the sine ratio. So find the sine of A and sine of B, write it as a fraction and as a decimal. So we're going to do both. So sine of A. What that means is we take our opposite side and we put it over our hypotenuse. Okay, so if angle A is here, the side opposite that is 8. So sine of A equals 8 over, and 17 is the hypotenuse. So there's your decimal answer. And then sine of A in terms of, or I'm sorry, there's your fraction answer. And in a decimal, you would just divide those two numbers to get 0.4706. So there's that. Now when we change it to do sine of B, our opposite side is not the same anymore because we have a different reference angle. We are referring now to angle B instead of angle A. So this time the opposite side is 15. So sine of B is going to be 15. The hypotenuse, however, is still the same. It's 17. So there's your fraction answer. And then when you divide 15 by 17, you get 0.8824 as your decimal answer. All right, second example right here. So using the sine ratio to actually find a missing measurement this time. So we have a reference angle of 53 degrees right here. This is the side opposite, and then this one is across from the 90, which makes this the hypotenuse. So because we're using our opposite and hypotenuse, we're using sine. Okay, so when we write this out, what we do is write sine of our angle, which is 53, and we set it equal to our opposite side, which is 22, divided by our hypotenuse, which is x. And then what we need to do is get x out of the denominator by multiplying both sides of our equation by x. So we get x times the sine of 53 equals 22. And then we need to divide by the sine of 53. So whatever that comes out to be, we need to divide by that. And I'm going to show you where these buttons are on the calculator. Unfortunately, you don't have a calculator yet of your own, so you can't really do much with this. So I want you to leave it here, but when we get into class, we're going to take it that step further and actually get the decimal form of that answer. All right, so I'm only doing that one example just to keep this kind of short and sweet because there's a whole lot, and we'll do them all in class just to make sure you're totally good. Okay, so moving on to cosine. So the cosine of A, what that means is that we are taking the side adjacent to angle A, and we're going to put it over the hypotenuse. So in this case, here's your angle A. Your adjacent side is next to it, so AC, and your hypotenuse is AB. And the hypotenuse and adjacent sides are never going to be the same thing. It's always, the hypotenuse is always a hypotenuse, and then your other two are your opposite and adjacent. All right, so cosine, you'll see sometimes I will write it as this. Cosine is adjacent over hypotenuse. So this one is doing cosine. So cosine of A equals, well, here's your angle, the adjacent side. So remember, we're doing adjacent over hypotenuse. So cosine of A is the adjacent side, which is 18, over the hypotenuse, which is 30. So here's your fraction answer. And then as a decimal, the cosine of A, you just take 18 and divide it by 30, which gives you 0.6. So there's your two answers for A. Then to move on to cosine of B. And now again, we are doing adjacent over hypotenuse, but the adjacent side isn't the same anymore because we're looking at angle B as our reference angle. So the adjacent side is now 24, but our hypotenuse is still the same. That's never going to change, and that's 30. So there's your fraction answer, and then your decimal answer would be 24 divided by 30, which is 0.8. So there's your fraction or decimal answer. So using the cosine to actually find the value of x. So in this example here, we have this angle as our reference angle, right? And then this side right here is our adjacent side, and this one over here, because it's across from the 90-degree angle, is the hypotenuse. So since we have A and H, that means we're using cosine. So cosine of 50, remember the angle always goes there, equals your adjacent side over your hypotenuse side. Now in this case, x is in the top, so all we need to do is multiply both sides by 10 to get 10 times the cosine of 50. And when you multiply by 10, your 10s cancel, leaving you with x. So we will, again, we'll finish that problem once we actually get into class together, and I can show you where the buttons are and how they work. All right, cruising right along into tangent. So tangent, this time, here's A. Tangent is taking the side opposite angle A and putting it over the side adjacent, to angle A. So in this case, the opposite is BC for angle A, and then AC for the adjacent. So that's all we're doing there. Then as we go on to do some problems, we have finding tangent ratios. So here's our reference angle here, and we have our opposite side, so the side across from it, and then we have the adjacent side. And we know that this is the adjacent and not the hypotenuse because here's your 90-degree angle and the hypotenuse is here. So we're using tangent because we have O and A. Actually, you should probably go back and add this to the little picture. Tangent is opposite over adjacent. So tangent of, and then put your angle measurement in here, equals your opposite side, which is 52, divided by your adjacent side, which is x. Now because x is in your denominator, we need to multiply by x on both sides of our equation to get x times the tangent of 39 equals 52. And then we need to divide by the tangent of 39. All right, and so these end up canceling, leaving you with x equals 52 over the tangent of 39. And again, we'll finish that up once we're in class. All right, and then we have find the leg length. So just another example. And so here we have our reference angle of 27. This is our opposite side, and this is our adjacent side. So we do exactly the same thing. Tangent of 27 equals the opposite over the adjacent. And so because x is on top, we just multiply by our denominator. And so we get 25 times the tangent of 27 is equal to our x value, and then we would actually find the decimal from there. All right, so that's your sine, cosine, tangent. And I know it's not a whole lot of information, but we have a whole lot of problems that we're going to do in class together. Now we move into what's called inverse sine. And what that does is it gives you the angle measurement. So you use this, use to find angles. Okay, so when you do your sine inverse, you take the opposite over the hypotenuse, just like always before. Okay, so sine before it was opposite over hypotenuse, it still is, but what the inverse does is it gives you the angle measurement instead. So for this one, if we're looking at the measure of angle A, or trying to find the measure of angle A, our opposite side is the 15. Our hypotenuse is across from the right angle, so it's 17. So we do sine of A equals 15 over 17. However, we're looking for this angle right here. So what I'm going to do is I'm going to take this 15 over 17 and put it in here. And as soon as I do that, I'm tagging this on here to make it the inverse and set that equal to A. Or I should even write just the measure of angle A. And so then once you divide that out, what you end up getting is that your measure of angle A is about 61.9 degrees. That's your measure of angle A. And I will show you exactly how to do that in the calculator as well. So inverse cosine. So cosine was adjacent over hypotenuse, and inverse cosine does the same thing, only we are finding angle measurements. So if we're looking for inverse cosine for the angle A again, remember you want your adjacent side and your hypotenuse. So if this is your right angle and that makes this your hypotenuse, which makes this your adjacent side. So we're going to take the cosine of A and set that equal to your adjacent over your hypotenuse. Now we're going to flip it. We're going to do the inverse, and we're going to take this 12 over 13 and put it inside the parentheses and put the measure of angle A after. And then what we end up getting for that angle measurement is about 22.6 degrees, and that's our measure of angle A. Okay? And then one more example and we're all done. So tangent. Tangent before was opposite over adjacent. Tangent is still opposite over adjacent. So again, we're looking for the measure of angle A here. The opposite side is this side, and the adjacent side is the one next to it that is not the hypotenuse. Remember, this one is the hypotenuse. So we will write tangent of A equals opposite 12 over adjacent, which is 16. But to get the measure of angle A, we have to do the inverse and put 12 over 16 in the parentheses, and that will give us the measure of angle A. So when we actually put that in the calculator, it gives us about 36.9 degrees as our measure of angle A. Okay, so we'll do all kinds of practice when you get into class, so make sure you have it all written down, and we'll finish it up when I see you.